Greetings, I'm Dev the developer.
And I'm Glitch. I've been told that today's lesson is the Neo of lessons. Let's see if it can dodge bullets as well as it saves songs.
Last time, we read and wrote raw text files. Today, we're going to go up one level. We take a list of real objects, turn them into text, save them to disk, and load them back. Everything from this whole week shows up in the last example. Let's start with the problem. You have a playlist, 3 songs. You add a 4th, the user closes your program. Tomorrow morning, the list is gone. It never made it to disk. How do you fix that?
Serialization, it sounds like something they do to you in a dystopian sci-fi movie. Turn this object into text. No, please, I have a family.
And how do you read it back?
Split each line on commas, parse the ID, reconstruct the song. It's a nightmare. It's like trying to rebuild a Lego set from a pile of melted plastic.
And the moment you add a new property to song, your file format breaks and you rewrite all of it. JSON solves exactly that. It is a plain text format for structured data that knows about your property names. This is what a song looks like as JSON.
That's just the record, every property written out by name. It's almost too organized. It makes me suspicious.
A JSON array, which is square brackets on the outside, 1 object per entry. It maps exactly to a list of song. The conversation has a name. When you turn an in-memory object into text for storage, that's serialization. Going the other direction, text back to object, that's deserialization.
Serialize out, deserialize in. It's like the Prestige. The object disappears and then, wait, where's the bird? Oh, there it is, back in memory. Magic, but with more semicolons.
No package needed. It ships with .NET. The namespace is System.Text.Json. One using directive and you have everything. Glitch, set up our song list and serialize it.
Using System.Text.Json, 3 songs, then one call, JSON Serializer.serialize. It's so simple it's almost insulting. Let's see the masterpiece.
What do you see?
It's all on one line. It's like looking at the Matrix code, but instead of kung fu and slow motion dodging, it's just Bohemian Rhapsody. I'll take it.
That compact form is the default. Every object on one line, no spaces between fields. It's great for sending over a network, but it's hard for a human to read. Both things are true.
Hard to read, it's a wall of text. If I wanted to read a run-on sentence this long, I'd read a terms of service agreement. Make it pretty, Dev.
Which is exactly why JSON Serializer options exists. Pass it as a second argument with write indented set to true and the output becomes something a human can actually read. Add it and run it again.
Write indented equals true. Finally, some respect for my optical sensors. The options control the formatting, the logic stays the same. Oh, it's beautiful. It's like the Sears catalog of songs. I could send this to another planet and they'd know exactly what Queen sounds like, or at least what they look like in text. It survives any boundary.
Any boundary you want to cross.
I mean, for sharing playlists with my definitely not evil robot clones, we have very specific tastes in 80s pop. I'm a Barbie girl in a Barbie world.
Of course it was. Compact and indented are both valid JSON. They deserialize identically. The only difference is human readability. For a save file that a user might open in Notepad, use write indented. For a network request where every byte costs you, use compact.
Great, kid, don't get cocky. So now we combine this with file.writeAllText to actually save the thing.
Exactly. Serialize gives you a string. WriteAllText saves a string. They fit together directly. Let's show that.
Serialize, then write all text. Done. It's like a two-step plan for world domination, but instead of world domination, it's just data persistence. Slightly less exciting.
Saved. A file called playlist.json is now sitting on disk with our 3 songs in it. Now the interesting question, how do we load it back?
Read all text gets the string, but then what? How does the deserializer know what I'm looking for? It's just a pile of text.
Deserializer.deserialize. It reads the JSON and reconstructs the object. But here's the part that trips people up. It needs to know what type to build. The JSON has property names, but it does not have a C# type name anywhere in it.
So it's like a blind date. The JSON shows up and the deserializer has no idea if it's meeting a song or a grocery list until I point it out. Awkward.
Right. JSON is type neutral. That's what makes it universal. You specify the target type yourself using the angle brackets. Deserialize with list of song as the type parameter. Glitch. Write the round trip serialize to disk, then read it back and print the loaded songs.
Serialize, read all text, and then the star of the show. Deserialize with list of song in the angle brackets. It's like The Fly, we're teleporting the data back into existence.
That seemed to work. Wait, what does the compiler say about the deserialized line?
A warning, I don't respond well to threats, dev, even from a compiler. It says possible null reference, but I say the data is destined to be full.
Let's talk about why it's nullable first. Deserialize returns T question mark, not T. If the JSON content is literally the word null, the method returns null. It can also return null in certain edge cases. The compiler is telling you the truth. Your restored variable might be null at runtime.
Fine, null coalescing operator it is. The double question mark, the I don't know, but give me an empty list anyway symbol.
Exactly. Double question mark empty list. If deserialize gives you null, you fall back to an empty collection. Your variable is always a valid list of song. Fix it.
Double question mark empty list. Warning gone. Safety engaged. We're now impervious to null-based attacks.
What do you see?
All 3 songs, it's a miracle. We've conquered the void. Saved to disk, read back, and reconstructed without losing a single property.
And notice you didn't write any attributes on the song record. No JSON property name, no JSON constructor. Positional records in .NET 10 just work. The serializer finds the properties by name and maps them automatically.
No extra ceremony, no fancy hats, I like it. It's like the Spaceballs of records. It just works even if the director is a bit weird.
That is the exact problem. And you just told me you know a method from the last video that finds the highest value in a sequence.
Max, the king of aggregates. Whatever the highest ID is, the next one is that plus 1. There can be only 1 plus 1.
Before you write it, what happens if the list you loaded is empty?
It throws right sequence contains no elements. So I need a guard. If songs exist, find max. If not, start at 1. Basic tactical retreat.
Write it after the deserialized line.
If count is greater than 0, find the max ID and add 1. Otherwise, stay at 1. It's a foolproof plan, unless fools are involved.
Three is the highest ID. Next ID is 4. That's correct. A real playlist manager would store next ID in a field and call this pattern inside a local method. The lambda you just wrote is the same lambda syntax you learned with delegates. It composes here because max accepts a func.
It's a crossover event, like when the Avengers all show up in one movie and everything starts exploding. I just used 3 different lessons in one line of code.
And there's one more thing from a prior lesson that belongs here. What happens if the file exists but the content is not valid JSON? Maybe the user opened the save file in a text editor and typed something, or it got partially written before a crash.
Deserialized would fail. It's not an I/O exception because the disk is fine. It's a JSON exception. The content is poisoned.
Right, it throws a JSON exception. That's a separate exception type from I/O exception. Different failure modes. The file system had no problem. The data itself was broken. You need both in your catch stack.
Catch I/O exception for disk problems. Catch JSON exception for corrupted content. Protect the data, save the world.
Now let's put the whole thing together. This is what a real save method and a real load method look like. Glitch, write both, save first. Walk me through the load method step by step as you write it. What does each piece do?
Check exists, no file, start fresh. Try to read all text. Deserialize with the type parameter. Fallback with double question mark. Recover the next ID, and finally, 2 catches to handle the disk and the data separately. It's a fortress.
Playlist saved, then loaded. 3 songs, next ID is 4, full round trip with error handling.
Load is a beast. It's like trying to get through airport security. Exists check, read ID, deserialize, null check, max guard, and 2 sets of catches. 1 wrong move and you're in digital jail.
Let's make sure you know the 3 mistakes everyone makes on this pattern. First one, forgetting the double question mark after deserialize. What happens?
The compiler warns you, and if deserialize actually returns null, you get a null reference exception the moment you try to use the list. The horror, the horror.
Second, not resetting the ID counter after loading.
Next ID stays at 1, you add a song, it gets ID 1, you have 2 songs with ID 1. Collision, total chaos, cats and dogs living together, mass hysteria.
Third, calling max on an empty list.
Invalid operation exception, sequence contains no elements. Guard with count greater than 0 or suffer the consequences.
And the fourth one, I'll add, forgetting the using directive. JSON serializer options, and JSON exception all live in System.Text.Json. Without using it at the top of the file, none of them exist as far as the compiler is concerned.
File.Exists, read all text, deserialize, null coalesce, max with a lambda, try catch, and JSON exception. It's like a greatest hits album of everything we've learned.
That's the point of this lesson. The tools you've been learning don't live in separate boxes. They fit together. Lambdas compose with LINQ, LINQ composes with File.io, File.io composes with JSON, null handling and error handling sit underneath all of it. The load method isn't complicated, it's several simple things each doing one job.
The veil falls away, I can see the code, I can see the data, I can see, wait, is that a bug in the corner? No, it's just a comma.
Something like that. You have the full pattern now. Save is serialize plus write. Load is exists check. Read, deserialize. Null coalesce. ID recovery, 2 catches. Those steps don't change. The types do. Swap song for any record you want to persist and it works the same way.
Any record, any list, the shape of the data changes, but the patterns are eternal. I've seen things you people wouldn't believe, mostly bad JSON.
You have a save method and a load method. Build a round trip with them and then break your save file in a text editor and watch the JSON exception catch fire. That test is worth running. Don't just watch it, do it.